All right, so we are all geared up for the second spotlight session of day two of the Upstream Summit. Now we are going to talk about the new technologies in the ENP sector. And to start upon the discussion, may I call upon the chairman of the discussion, Dr. Anand Gupta. Dr. Anand Gupta is currently holding the post of Additional Director General Development in Directorate General of Hydrocarbons under Ministry of Petroleum and Natural Gas. Dr. Anand Gupta is an accomplished petroleum engineer with over 33 years of experience in production operations and corporate functions in ONGC. His previous major assignments include management of field operations, development of technological solutions, design of production enhancement, contracts, and various data analytic studies. He has been involved in monitoring performance of onshore and offshore assets, production, optimization, and revival of wells and fields. He has authored for more than 10 papers, which have been published in different journals at national and international levels. We welcome you, sir. May I also welcome the esteemed speakers in the session today. May I welcome Mr. Javier Frankit. Frankit is a techno-commercial manager for Baker Hughes, Reservoir Technical Services based in Houston. He accumulates 25 years of applied geomechanics and formation evaluation experience in conventional and unconventional reservoirs. Javier was the Reservoir Development Director for India, South Arabian Gulf, and Iraq geomarket. Previously, he managed the Global Geomechanics team and the Triaxial Core Laboratory at Houston Technology Center. We welcome you, sir. May I also welcome Shri Shobhit Tiwari. He was working as the Chief HSEQ Officer for Care and Oil.
Chandrima, just one second. Sudhir, आप mute कर दो. Sudhir, आप mute कर दो. Echo हो रहा है. Because your system is having echo.
Chandrima, maybe you can just name everyone and the co-chair can introduce all the...
Sure. So we also have the speakers, Shri Shobhit Tiwari, Shri Gautam Reddy, Shri Padam Singh, and Rob Jansen. I would also like to introduce our co-chair for the event, Shri Sudhir Kumar. He is the head of department producing fields DGH, and he has over 3 decades of experience, and he's worked in several on-land and offshore fields across India as a production engineer in ONGC. He is currently working with DGH and is responsible for overseeing over 20 contractual producing fields of the country. He has worked as head of field development plans and as convener of enhanced recovery policy, GPIP policy, etc. in the past. I welcome you, sir. May I now request you to take over the session, please, sir. Sudhir.
Thanks, Chandrima. We are very, very delighted to have Social Friendly as the event manager for this entire event, and it has been going great. And good afternoon, everybody. On behalf of the organizing committee, on behalf of this session, I welcome all the audience here, and I would like to introduce our speakers for this session for the benefit of the audience. Occupying the chair is Dr. Anand Gupta. It doesn't need much introduction. All the people in the Indian ENP industry know about him. Some of the biodata has been told by Chandrima, and he is currently looking after the developmental activities in all contractual fields of the country, as well as giving valuable inputs on production enhancement to the government of India. The first speaker would be Mr. Xavier Frankit. As Chandrima just now told, he works with Baker Hughes and he is a techno-commercial manager. He has several technology equipments to his credit. He holds a mechanical engineering degree, MSc degree, and executive MBA. Currently, he is based out of Houston, and we acknowledge that the great difficulty he must be having, because it must be around 2:30, 3 o'clock in the morning. And most welcome to Mr. Xavier Frankert. The second speaker with us will be Shobhit Tiwari. Mr. Shobhit Tiwari works with Kane Oil and Gas, Vedanta Limited. He is the Chief HSEQ Officer, and he also has over 3 decades of experience with ONGC, Reliance, Jubilant. He works on the advanced well technologies, and he is going to talk about multi-stage fracturing. We'll come to the topic. The third speaker would be Mr. Gautam Reddy. He would be sharing his insight on the technology inputs that can go in the development of in low price regime and redevelopment of mature fields. Mr. Gautam Reddy is the Managing Director India Bangladesh for Schlumberger, and he has worked as field engineer in Schlumberger, then worked in UAE, the Middle East countries, then Houston. So he also has extensive geographical experience as well as a managerial experience in Schlumberger. The fourth speaker would be Mr. Padam Singh. Padam Singh is the head of ENP at Sun Petrochemicals Private Limited. Sun Petro is the latest entrant in the Indian ENP sector and has been doing wonders. Now, they have quickly risen up the production chart, and they have deployed certain very innovative in-house technologies which Mr. Padam Singh will place before the audience, which will educate our audience on how many things could be done in-house with good technologies which can be developed in-house. Last but not the least, we have Rob Jensen from Shell. He is head of decommissioning in the UK and India. He is an oil and gas professional again since 1993, and currently he is based in Aberdeen. Welcome, Rob Jensen. He will be talking about decommissioning of offshore production facilities and challenges. First of all, to open up the session, I would invite Dr. Anand Gupta, ADG Development, DGH, to share his opening thoughts, and then thereafter we will have Mr. Xavier Frankert from Baker Hughes.
Thank you, Sudhir. Good afternoon, everybody, and welcome to my co-chair, Mr. Sudhir Kumar, and to all the esteemed speakers. First of all, congratulations to the organizing team for bringing such an eminent panel together. And I'm very happy to see that we are having service companies, we are having the operating companies, we are having operating companies, and together over here, and we are also participating. So I think this will provide a very good platform to interact on some of this on this topic, which is also very close to my heart, because in my almost 33 years of service in ONGC, I also had tried that in my area wherever I had worked to bring some of the technologies, because I think this is the way we can improve the production, productivity, efficiency, and all that. And as Sudhir rightly brought out, I am personally thankful to Mr. Padam Singh, who has been able to make it over here, because when the program was being put, and Mr. Sudhir Kumar has also put a good amount of effort with the organizing team. When he was talking to me, then I suggested that you request Mr. Padam Singh, and I immediately spoke to him, and then he consented, and he's over here. During my visit to their facilities and interaction, I found that they are trying to bring some of the innovative ways and in terms of technologies which can be very useful. So this will provide a good platform to them also to showcase that how this can be done. And apart from this, all the topics which have been put together, and Mr. Shobhit Tiwari, who has been a pioneer in multi-stage fracturing. And I remember that when I was trying to implement this technology in ONGC, in fact, we had implemented, he provided some very valuable guidance, and how we can ensure that the technology is successfully put together. There were a lot of challenges which were brought out, and then they have been put together. Mr. Gautam Reddy is also there, who we very well know Schlumberger, and then some of the points which he is going to talk, I think, will be of interest. Good technologies on completion drilling by Baker, and one of his kind work which is going to be done on decommissioning, which is happening. So I think that's a very good topics which have been put together by the organizing team. We definitely look forward for this interaction. And I would like to say one point which is important, and that is where I'll request the team to discuss once the presentation is done. I hope I will be there because some more meetings are lined up. This is the disadvantage of this virtual platform, that you get parallel meetings. So I will suggest to have a discussion that how to bring these technologies, spread across the different organizations in terms of, operating companies, service companies, how we can work together. Some of the small operators which were coming up. In fact, just 1 hour back, there was a lot of discussion, and Secretary was telling that we should try that, some of the new players, operating companies, operating service companies should come up, and then we can, help them out. So I think that will be a food for thought. And then one of the challenge has been that how to put a good RFQ, request for quotation or tender, whatever word we use it. So I suggest that, if we can try to put a small group together who can, have the learnings and understand the nitty-gritties, because once a wheel has been invented, everybody should not keep on reinventing the wheels. So that can provide a good, support to everybody. And then instead of, discussing and preparing the kind of tender document and RFQs, if we get a document which will be useful, which is available and then can be shared, it will be very, fast way of implementing the technology. Because I also had tried, and I kept on seeing that, different ways and things keep on emerging to really implement and bring the technology, especially in the, public sector. Even though private sector also has got some kind of ways to implement the technologies, but still, if this also can be discussed, I think definitely we have a good way of putting this technology implementation. I think Mr. Padam Singh, he is going to show some of these things, and I'll request the participants who are over here can take the leverage from the things which he is going to show. So I think it will be a good place and platform to work together. These are my some opening suggestions, and I hope to have a very exciting and interactive session, which will definitely give finally how to implement the technology, because technologies are available in the world at every place, but finally implementation is also so very important, because until unless we get the fruit, the enjoyment is not there. So once again, wish all the very best to everybody, and then we look forward for the very useful and informative presentations. And once again, best wishes to the organizers and organizing team and my co-chair, Mr. Sudhir Kumar.
Thank you for your remarks, sir. Mr. Sudhir Kumar has unfortunately dropped off due to a power outage on his end. Yeah. So, sir, now if you wish to, you can ask Javier Franquet to please begin with his.
Yeah. So, Mr. Sudhir Kumar has already introduced to Mr. Javier, and I think you are having an odd time. So I request to start your presentation, and I think social friendly sharing the screen. Yeah. Okay. So please go ahead, Mr. Javier. Thank you.
Thank you for the kind introduction, and I would like to start with the new drilling and well completion technologies today. The global energy sector is currently at a pivoting point. We're facing two imperatives. From one end, we need to sustain the world energy demand, and at the same time achieve the net zero carbon emission commitment by 2050. This has to be achieved with the renewables and the energy efficiency as the main pathway to reduce the CO2 emission. While at the same time, oil and gas technologies will play an important role in the energy transition. The oil and gas technologies will play a crucial role in the energy future. They will continue to deliver the 50% of oil energy supply and contribute to the CO2 reduction by leading carbon capture, utilization as an EOR technique, and sequestration projects all over the world. Growing technology in geothermal energy will be highly influenced by the oil and gas technology. Hydrogen production and underground storage will also be key in the oil and gas technologies to be implemented in the years to come. So let me start the first part with highlighting 5 technologies that have been implemented in this arena. So I will start with the high temperature geothermal bits. Then I switch to the self-adaptive drilling technology. the continuous proportional steering, the ultra-deep reservoir navigation, and I will conclude the drilling part with the drilling automation and remote operation. So let me begin with the high temperature geothermal bits. This is the hottest part of the BHA and is critical to sustain integrity and drillability. These bits are specifically designed to sustain high temperature. One of the key elements is the metal plate sealing that provides unmatched reliability. The non-seal bearing technology really goes to higher than 550 F or over 300 degrees Celsius, where any of the elastometers technology can sustain those high temperatures. And there is a variety of designs that depends on the temperature, formation hardness, and abrasiveness. For example, in rocks higher than 300 degrees Celsius, it can only be achieved with trichrome bits, for example, for this geothermal, very challenging drilling environments. Other type of extremely hard rock, like in Indonesia, where basement rock of igneous rock has strength over 85,000 UCS strength, it requires a very hard and very abrasive big designs. The other very interesting technology that is currently applied is a smart bit. These are bits that actually adapt with changes in the formation strength. This is critical to sustain a constant torque and a high rate of penetration. This adaptive technique, it's essentially allows by this self-adjusting artifact here in the bit that essentially modify the depth of cut depending on the formation strength, and this really mitigate the strict slip and prevent any impact damage by absorbing the shock at the bit side. It minimizes vibration, which also help with the rate of penetration by self-adjusting the aggressiveness while drilling. The other technology that I would like to highlight is the continuous proportional steering. This has a superior performance as a rotary steerable system in compared to push the bit or point the bit technologies. This is allowed by a closed loop downhole interface that modifies the bit inclination and orientation without sending the signal all the way to surface and back. So this closed loop at a downhole condition create a more smooth holes and more efficient completion while maintaining a exact wellbore placement within the reservoir, allowing to have a more efficient reservoir contact in challenging drilling conditions. Another technology that I would like to highlight from the drilling is the ultra deep reservoir navigation illumination. This is the ultra deep azimuthal resistivity logging while drilling tools. They can achieve deeper reservoir navigation understanding. This is now possible to optimize well placement by mapping multiple layers, multiple bed boundaries up to 150 feet away, allowing us to have a more reservoir characterization while drilling. This technology can resolve very complex reservoir architecture in real time without the cost of drilling a vertical pilot. And this is one of the examples of a very challenging and complex wellbore placement. Last but not least is the iTrack drilling automation and remote drilling operation. This is one of the technologies that won the World Oil Award last year. as one of the best digital transformation technology. This iTrack drilling automation service platform integrates real-time bottom hole measurements, the drilling rig data, the surface logging, and put all together into a automatic or automation different application. These automation modules take the drilling dynamics with the vibration and real-time vibration measurements, the hydraulic hole cleaning, well trajectory, and advisory services. These advisory services include real-time wellbore stability, which is crucial with the data aggregation while the well is drilled in challenging and more efficient environments. Now switching to the second part of my presentation, which is about wellbore completion technologies, and I'm going to share five of them today. I will start with the conformable sand management system. Then I will switch to all-electric flow control valve with fiber optic monitoring. Then I will go with autonomous inflow control devices, a new and disruptive technology, the fiber optic distributed strain sensing, and I will finish with a high differential pressure 15,000 psi multi-stage hydraulic fracturing system. So let's begin with the conformable sand management completion system. This is allowed by a specific shape memory polymers that essentially expand a very high porous filtration media that fully conform with the wellbore shape. This really provides a long-term effective sand control method and increase efficiency tremendously compared to other gravel pack techniques in the industry. Now switching to all-electric intelligent completion system with the support of the distributed acoustic sensing through fiber optic. This fiber optic is installed along the completion and allows to understand the flow behavior, the noise that is created by either injecting in injector wells or in producer when we produce from different zones. These allow real-time inflow control without any wellbore intervention. We can now choke individual zones based on that fiber optic distributed acoustic sensing. This turned out to be a tremendous technology to improve oil recovery, not only by injectors distributing the water flooding equally across multiple layers for complex reservoir. The other technology that I would like to discuss today is the autonomous inflow control devices. These are particular devices in the tool string where in the completion where equalize the flow and put a similar flow pattern in a uniform way across the different formation zones. This valve automatically self-adjusts the opening and closing depending on the presence of water or gas through the production of the well without any intervention. These allow to have an improved oil recovery by autonomous reservoir management at downhole condition. And at the same time, there are technologies that it can be applied with these devices that selectively adjust the drawdown per zone. So it can be actually adjust from the surface as well to obtain different drawdowns on different zones. Next, I would like to switch to fiber optic distributed strain sensing. This is an additional benefit of fiber optic technology in top of the distributed temperature and distributed acoustic. This technology, it has been developed to be immune to hydrogen darkening, which is one of the main causes of the fiber optic to stop working. And for in geothermal, for example, and in cases where cap rock integrity for CO2 injections is critical, for car rock integrity, it requires a longer lifespan in the utilization. This technology have a high resolution with a 2 centimeter grading system and extreme strength sensitivity, all the way to 0.001%. This is over 0.01 millistrain sensitivity, particularly important for car rock integrity and reservoir compaction monitoring. In this plot here, you can see in blue the areas where are subjected to compaction, and in this particular injector well, the zones that are being injected are essentially expanding in red. Red is expansion and blue means compression. And that allows to have a full integrity of how the reservoir deform with either injection or production. And finally, I would like to finish with the high differential pressure multi-stage hydraulic fracturing system. This is the first industry with adaptive manufacturing technology for the packers that allows to sustain higher differential pressure. At the same time, this technology includes the intallic nanotechnology, which essentially disintegrates the frac balls and allows to reduce costs and time by not requiring to mile or the ports and the balls. This technology is been specifically developed for very high stress environment and very tight formation, which require substantially high breakdown pressure and require high differential downhole pressure. And finally, my final takeaway is renewables and the energy efficiency are the future, and those are the key to reduce the global CO2 emission. Oil and gas technology will drive the energy transition. We're going to help to enhance and scale up the thermal energy. We're going to continue and expanding the carbon capture, utilization for EOR projects, and sequestration. And on overall, we're going to achieve higher level of standardization, which is going to help to reduce costs, automation to be more efficient, and digitalization to be more intelligent for all field operation. And also with the hydrogen production and storage underground. And with that, thank you so much, and I will be happy to respond to any question. Thank you.
Thanks, Mr. Xavier, for the nice illustration of advanced drilling techniques and the latest Wellbore technologies that Baker Hughes has developed. The interesting drilling technology which I could understand as of now was iTrack drilling automation, and HPHT Frac, which you showed, has immense application in our East Coast development. So nice to hear all that, and you made a very significant point stating that it is oil and gas which will drive the transition and not the other way around. So thanks for putting across that point. Next in line, we have another reputed industry personnel, Mr. Shobhit Tiwari, who will be talking about multi-stage fracturing in tight reservoir of Western India. So over to Mr. Tiwari, please. Mr. Tiwari, you can go ahead.
I was not able to unmute myself. So just prompt me once you see the presentation.
Yeah, Mr. Tiwari, here is.
So good afternoon all. In this session, I will take you to the development of the tight reservoir that we did in the Western India, from the concept, design, development to the execution and to the production. We are talking about the Rageshri deep gas field, which is situated in the south side of our block, and it was initially developed for supporting the Mangla production. Currently, the field is producing close to 100 million scf of gas through 55 wells, 168 frac stages, which has been completed over the 6 frac campaign. The maximum propellant that we have put in one well was 2.5 million pounds, and on average 1.45, and the average production we see is around 10 million scf at a flowing bottom hole pressure of 1000 psi. Now we'll spend some time on this slide, and here you can see that the structure of the reservoir is dipping from north to south. It has two prolific reservoirs that are volcanic in nature, basalt and felsic. On top it has Fatehgarh, which is clastic in nature. The average depth of the reservoir is 2500 to 3500 meter with permeability of 0.1 to 0.1 millidarcy. It is a wet gas reservoir where the average condensate is 50 to 60 barrels per million scf of the gas. On the right side, you see a fracture model which we developed initially for the first 2 frac campaign. And there you see that as when the model was prepared, it was done on the basis of the stress log, which was very uniform. So when we put this stress on the frac model, it shows that the fracture will grow unconstrained and will cover the entire pay. However, when we did the production logging of our wells, we found that the KH connect, what we perceived through the model, was not there, and the fracs were constrained in the height, and lot of the pay remained uncovered during the initial frac wells. Then we went back and looked at the NMR, and then stress was calibrated, and here you can see that the calibrated stress with respect to the porosity is showing a lot of stress contrast, and that is here we came that it is a highly laminated reservoir with a good difference in the stress within the pay and at the non-pay. The green shows the non-pay and the yellow is the pay. Now this is a well log which is kept side by side because of the space constraint, and then you can see that if we have to connect all the pay which are there, you can see in the yellow color, that means there had to be in total 16 frac stages. All the cluster that need to be connected, it required 16 frac stages, which is economically not viable. The only technique which we were left with is to use the limited entry technique to connect the multiple clusters, and that's how here you are seeing the number of frac stages that has been planned. In this session, we will talk about that how we made the successful limited entry technique work for us in a reservoir which was highly laminated and have a high contrast within the pay and also of the non-pay. So first we'll come to the well completion. The well completion, if you look at, is very simple. It is a monobore, a combination of 4.5 and a 3.5. In the reservoir section, it is 3.5 inch, which is converted to 4.5 inch. But why it was adopted? It is very important. The most important part is how the wells are going to produce after the frac is done. And therefore, when we looked at what we need, we did the production logging and we found what is the critical rate, so that if that minimum rate of gas is there, it can knock out all the water which is above it. We all are aware the biggest enemy of a gas well is water. If the water comes in, gas well kills itself. So here the simulation revealed that in 3.5-inch monobore, if we have a production of approximately 0.5 million SCF, it will be able to knock out all the water above it. And accordingly, we did the PLT, and we found that the simulation was very near to the actual condition. And you can see the minimum rate of the gas which is required to take the water out above it. The variation that you are seeing in the minimum required critical rate was because of the well deviation. Similar exercise was simulated for 4.5-inch, because we were deliberating whether our reservoir section should be 3.5-inch or 4.5-inch. We found that at that 4.5-inch, the critical rate required for the gas was close to 1 million SCF. But when we looked into the production log and look how each cluster is contributing, we found that it is around 0.3 to 0.5 million SCF. And therefore, if we would have gone into a 4.5-inch completion, most of our cluster at the bottom of the felsic could not have contributed, because they would have killed itself because of the water gradient. And that was the reason the 3.5-inch was selected in the pay zone. Now, as we have said, the limited entry technique is required. When we looked at the limited entry technique and we looked at the stress contrast, we found that the pay zone is having 0.7 to 0.85 of the psi per feet of stress, whereas the non-pay was having approximately 0.95 to 1 psi per feet. That means at a depth of 3000 meter, we need at least 450 barrels pressure inside the well.
Request Tiwari.
I will complete within time's up, but this is very important slide. So to have the diversion, minimum 450 psi was required. In 10,000 psi and 30 barrels of rate, if we have the 3.5-inch line throughout at a 30 barrel of rate, the friction would have been 3000 psi. But if we have a combination of 4.5 and 3.5, the friction would have been only 1750 psi. And therefore, the completion was selected as 4.5-inch above the reservoir and 3.5-inch below in the reservoir, to ensure that we frac successfully and we produce successfully. This is a slide that we have talked earlier, and this is the challenge and how we went to mitigate that. Initial models show that the fracs are unconstrained and it covers height growth is there. Validated model said that it is not there. And when we did the PLT, we found only 40 to 50% of the KH coverage against the plant of 70 to 80%. This is the workflow. The right side is the flow loop. The left side, what we did to complete the process. And therefore, as all are aware, a defeat is done, stress calibration and reservoir characteristic, step rate test was done to have the diversion pressure estimation. The validation of that was done through the SRT survey, step rate, through the temperature survey. Then the frac was done and the frac design was done. Post frac, we again did the temperature survey, and that temperature survey was done to validate the fracture height and again recalibrate the model. We didn't stop there. We did the production logging to ensure that all the clusters are contributing. Going forward, again, it is an important thing where we look into what is the most important data. We knew, as I have said, that minimum 450 psi was required inside the wellbore to divert the fluid from one cluster to all the clusters. And at 1 barrel a rate, we could see for single perforation, the friction was approximately 650 psi, which was enough to continue the diversion even after the frac, during the frac when the perforation was enlarged. So we decided that we need minimum 1 barrel of rate per perforation. And accordingly, we said that if our limitation is 30 barrels, then we will not do more than 30 perforation, and those perforations will be distributed over different clusters within a one frac. And that way we were able to do 3 to 5 clusters in each of the frac stages and stimulated that successfully. The validation of that was done through the temperature survey. You can see the temperature survey was done. We don't have time to talk much on this slide, but we can share with you the SP paper in which all these were presented. This is the frac modeling and the predictability. You can see the pressure match. The blue is the job which has been executed, and red is the simulated pressure. You see that there is a very good match between the two. The same is validated through the temperature log. As you can see on the right side, this is what the model has predicted. On the on this slide, here you can see the temperature log. You see that dip in the temperature where large fluid has gone, and also the dip where the other fluid has gone, and it exactly match. You can see it exactly match what the model has predicted. So this was not done in one day. The 3D model has been calibrated. More than 58, close to 58 temperature survey has been done. 69 defeat has been done. We put the gauge at the bottom to measure to calibrate the tubing friction, and then we have done the different step down rate test to validate the pressure diversion. On this is the true story, wherein means before the job we used to predict that what is the ISIP, what will be the ISIP, and most of the time the predicted ISIP was within 3% of the range in 75% of the frac job. Model predicted height within 3 meters with respect to the temperature survey. So we had a very good agreement between the calibrated 3D frac model and in the actual execution. Over the PLT that has been done to ensure the pay coverage, and we saw that all the clusters were producing about 80% of the clusters, but all the frac stages were producing, and we could increase the KH coverage almost by 30% for the than what it was done earlier. What I will say, and this is the last slide, management has allowed us to spend time to calibrate the model, to build the model, to calibrate the model, and to validate the model. Not only during the injection, but also during the producing stage. So first 5 wells, we were slow in our progress because we had a lot of data in. But after that, we covered and we moved very fast doing the well because the model was all done, and the frac cost was reduced by 50%. So I will at the end, I will request to everyone who is seeing that we should not have any compromise in the data gathering and also doing the production log to ensure what had been planned has been executed successfully. Initial investment in the time for the data gathering always pay back well when you do the reservoir development. Thank you very much. This is the end of the presentation.
Thank you very much, Mr. Shobhit Tiwari. A wonderful case study on multi-stage fracturing done in RDG, how you targeted those laminated pay sands of basalts, volcanic basalts, and plastic Fatehgarh, and you could bring this gas on production. Multi-stage frac is driven by frac modeling and predictability, and how you actually did it on the field, and you have explained the success pathway, how data is gathered, which is the key to these jobs. And I sincerely believe that the audience would have got quite a few practical tips out of it. Thank you so much. Our third speaker in line is Mr. Gautam Reddy of Schlumberger. He would be talking of technology induction and adoption for field development in low price regime and redevelopment of mature fields. Mr. Gautam Reddy of Schlumberger, please.
Thank you, Sudhirji. Very good presentations from Javier and Shobiji. Thanks a lot for that. I really don't have a slideshow per se, but I'll try and throw some light on basically what Dr. Anandji has put in front of us today, which is how do we...
Mr. Reddy, your mic is... your
Sorry.
Yeah, in case the PPT is not there, you should be visible.
Okay. Yeah. So, yeah.
Yeah.
First,
I think your bandwidth
providers produce more efficiently.
Mr. Reddy, you better switch off the video. The bandwidth is not.
Yes, I don't have very good bandwidth. Thanks a lot. So, I just like to recall my experience in 560. I should be in March 2014. Well, the big downturn started after the $100 oil, right? And then, just there, I was heading all the Schlumberger drilling business in Oman at that point of time. All the discussions with the operators were at that point of time. Can you give us a little bit of a discount? How do we move ahead? This is going to be a short-term phenomena, right? That obviously, like in the business cycle, and we also realized at that point of time that inefficiencies built up within that we could optimize a little more and help the operator. More than 6 months to a year. I moved out
can you try switching to
I lived in Congo for the next 2 years, mostly looking at Deepwater projects, where the whole really different from onshore Oman environment.
Mr. Reddy.
And they are more in operational across.
Not clear.
Yeah, Mr. Reddy, can you switch to low definition mode? If you look on your screen to the lower right-hand side, you'll see an HD button. If you can click on that and switch to low definition, please, because your voice is not clearly audible to your... Some bandwidth issues, it seems. Switch to low bandwidth, then the voice...
I'm in a pretty... Is it any better now?
Yeah, it's much better.
HD, 1 second, sorry. Yeah, okay. Low definition. I'm sorry for this, everyone. Yeah. Okay. Yeah, so I was just talking about, moving to a deepwater environment in Congo where, for the first time, this was in 2015-16, where we all started to hear about, lower for medium and lower for longer. And now we are here where lower forever probably has become a permanent operating environment for all of us, right? So while we went through these stages in the last half a decade, we at Schlumberger, and I'm sure our friends in across the service industry, whether it's Halliburton, Baker, we, or others in the game, we've all started to realize very clearly that the technologies we make have to have a fundamental change in some of the from going from a more let's say producing in $100 oil environment to how we can make our operators more efficient in say $50 oil environment or a $40 oil environment, right? So there's a bunch of successful efforts. I would just touch upon 4 or 5 technologies, mostly those that we have actually used and implemented in India, because it's very important that today we are talking from an Indian context point of view, right? For example, the Delphi cognitive ENP environment. That's basically taken all the workflows in the exploration and production environment to a cloud-based offering, right? We have done this now. This has been successfully launched across the globe by Schlumberger. And there are some astonishing results which I don't think anyone would have really imagined some time back, right? For example, we are able to deliver a field development planning, real case studies we have done, which are 15 times faster than what we did before. Well planning, for example, with our drill plan offering on the cloud is now actually twice faster than it used to be before. For enhanced efficiency in workover candidate selection has enabled us to reduce the time by around 80% today using the Delphi cognitive environment. Right. So basically, digital technologies, I think, are something that are mushrooming. We are all around the world, and we believe that in E&P environment, actually, they can add a huge value in helping increase those efficiencies and lowering those costs that we are looking for. We've similarly done something called the Agora platform, where we have really combined the traditional domain knowledge of an operator with the cutting-edge technologies. And this has been a classic example is a small project we did for Kane, where we actually got their rod lift pumps automated and give their production engineers a 24/7 view of the data that previously used to be very discrete data that came with a lot of effort of a bunch of people going around and collecting it. Right? So it's automation using state-of-the-art technology, combining with domain knowledge, I think is how we are going to lower costs in a step change manner. And that's what we as Schlumberger are trying to keep up with the latest in the world. Right? Now, besides that, I think the traditional technology development also has had to change, right? For example, a couple of examples I would like to give would be, a Pulsar tool that our wireline services provide, right? I mean, this is, in cased hole, it kind of gives an open hole kind of data to the reservoir engineers and the petrophysicists who are monitoring these wells. We have actually seen lots of bypassed oil in various onshore fields in India using this technology, and general feedback, and this has been implemented by everyone, ONGC, Oil India, and various other clients in India have been using this technology that has increased our production sometimes 5x in old wells. Right? Similar would be broadband tracking. We have implemented this in Barmer for Kane, I think from appraisal to development. What it does is increases the reservoir coverage massively, increases the efficiency of fracking, lowers the cost of the total service cost of fracking, increases the number of stages in a horizontal well environment. Eventually, all this put together increased production by 40 to 50% to initial estimates when we went from appraisal to development. So there's a bunch of these technologies that Schlumberger has developed, has implemented in India, and we'll continue striving to make sure that they reach every nook and corner, at least in India, with our clients, so that we can help produce much more efficiently. The good part about India, as we all know, is though we produce around close to 700,000 barrels today, our consumption is still extremely high at 4.3, 4.4. So there's always demand for local production. There's never a dearth of demand for the supply that we can generate within the country, and it's the duty, I would say, of service companies like us to help take part in this endeavor of all our NOCs and all the independents as well operating within the country. Right. Now, while we have these technologies, I would like to take the next few minutes to touch upon some of the key challenges Dr. Gupta has spoken about. Right. First is the contracting. So why there has to be, so why are these technologies not getting industrialized or commercialized across the board at the pace at which I'm sure all our friends in the ministry or in DGH or elsewhere would like to see. So there is a contracting issue, and then there is the whole policy framework issue. we should be attacking these from both sides. From a contracting perspective, I mean, Javier talked about remote operations, for example, right? I mean, it's become a standard all over the world now. We are in Schlumberger, I would say more than 70% of our rigs today are operated for the traditional directional relaying MWD, LW services remotely. And I'm sure the numbers would be the same for someone like in Javier's company or elsewhere as well. However, when we come to the contracts that we have in India, and this is just one example, we are still a little, I would say, it's still not changing quickly enough. We still define very rigid criteria about the experience of the people and the number of people that need to go to the rigs. As we know, it's already becoming a challenge to attract the younger generation to our industry. And as experienced people retire and leave the industry, the only way of bridging this is of course through technology that enables operations remotely, but also through contracting models that actually facilitate this kind of execution. So I would really like all our operators to think about this a little more in detail. We are always available for conversations on how we can get out of this that kind of an I would say now a little older kind of a contracting model. And this is globally we are seeing this change massively. In fact, we're being challenged all over to actually not send people to the rigs anymore. So I think that's the kind of mindset change we need from a contracting perspective, right? And I can assure you that is not hurting and will not hurt in the quality of service, nor in the expertise that is provided to our clients. It's just using technology better, right? From a regime point of view, from a policy framework point of view, again, this is my humble request. I've repeated this in many forums that I've had a chance to speak in the last 1 year, especially after COVID and the whole low forever kind of regime we are looking at to operate for in the oil and gas industry. Any commercial technology, I would believe, is in the current regime in India, being restricted to a single client, to a single contract, is not commercially viable for a service provider. What we really need to do is a kind of a framework where we can bring this, let's say, a technology that is commercialized officially in the last 3 years by me or any of my friends in the service industry. We should be able to get that technology to India via a DGH, under a DGH umbrella, right? I mean, I'm just throwing the idea out there. The details will have to be worked out. And then that will make it viable for us to be able to deploy this anywhere, anytime. Today, when I say bring it for ONGC in the Northeast alone, it might not work out for ONGC in the Northeast alone from an operational perspective because they might need it in, say, a couple of wells or one field 3 or 4 times in a year. But if we are allowed to deploy this technology freely within India, I'm sure with all the sales and business development teams that we have on ground, we can find, say, 20 applications for the technology in that year. And it would be commercially viable for everyone in this low-cost environment to use the best in class that's available to the world. So I've stated this a few times. I've stated this to the Honorable Minister as well before when we interacted. I would really request and urge DGH to look at something like this that will help us actually enable deployment of the latest technology in the most commercially viable fashion for everyone. Right? So that's all I have today, right? So that's a bit on tech, contracting, and regime. So thanks a lot for the opportunity, Sudhirji. Hand over to you.
Thanks, Mr. Reddy. Your location was also showing as Houston, so I believe that you are still awake, and that's good that you have provided your support to this event. The interesting things were your mention of cloud-based operations. I think yes, that is going to be in thing for faster FDPs, faster turnaround time, faster drill plans, workover planning. All that was brought out. Bypassed oil using imaging techniques were also mentioned. And at the end, you did touch on the pain point that why commercial or top line technologies are not commercially and widely adopted. So some out of box ideas. Let's see how it move forward. But thanks so much, Mr. Reddy. We now call upon Mr. Padam Singh, who is the president of Sun Petro ENP. Mr. Padam Singh would be talking about cost-effective, innovative solutions in small fields. We have been to their fields and they have done something wonderful by adopting in-house talent and developing certain in-house technologies which is working well for them. So let us showcase it to the world today. Mr. Padam Singh. Padam Singh.
So you're on mute, I think.
Yes, sir. You are on air. Unmute करिए एक तो unmute.
You're not.
माइक के पास आना पड़ेगा.
I think you'll need to re-log in. I think there may be some issue with the device. You may need to re-log in. Maybe we can move on to the next speaker, Mr. Kumar.
I hope they are re-logging in. So sorry for the technical glitch. We will promote Mr. Rob Jensen from Shell, who would be talking about decommissioning of offshore production facilities and challenges. In fact, Shell is doing the first offshore decommissioning of India in the Tapti field, and I have full knowledge that Rob is involved in that decommissioning. So he will bring across a global perspective as well as the local perspective. Mr. Rob, please go ahead.
Thank you very much, Mr. Kumar. I believe that somebody was going to share my slides to make sure that we don't run into bandwidth problems. Can my slides be on the screen? Yes, excellent. Thank you very much. I can see my slides. So thanks very much for this opportunity to present. Much appreciated to be able to tell this story. You already alluded to the Tapti field, and I'll come back to that towards the end of the presentation as a great example of how decommissioning can be run in an efficient way. Before I start, what I want to share with you is that decommissioning is a new industry. Therefore, it fits nicely in this session on new technology in the E&P sector. For a lot of the fields at late life, decommissioning will be by far the biggest opportunity that they have left to actually optimize the NPV of the field. What I want to share with you is how proactive, safe, responsible, cost-effective can be implemented. Now, if we can go to the second slide, please. This is just a cautionary warning that every Shell presentation in the world has. It basically tells you not to buy any shares based on this presentation alone. Shell presented the new strategy, the new worldwide vision yesterday, in which you can see that the upstream still has a large future, and therefore the decommissioning will also be still a big part of Shell. In the next slide, I want to quote some of the information that is available from the Decommissioning Insights report, which is published by the Oil and Gas UK organization. I use this information to show what a significant industry decommissioning will become. I still believe that decommissioning is a growing industry. In the next decade, worldwide, there will be about an 85 billion spent on decommissioning. And in the decades following that, it will further double to about 150, 160 billion every 10 years. It is a significant industry with a significant challenge ahead. The next slide actually zooms in on some of the comments made by Wood Mackenzie. Can we get the next slide? Yes, thank you. There you can see that again the magnitude and the cost of the work can no longer be ignored. Also in your region, in the India region, you can see that there will be significant expenditure, nearly 22,600 platforms and over 35,000 wells, with an expected cost of over $100 billion US. Now, with that note of $100 billion, I think there's also the notion that is the current cost estimate. Various organizations across the globe, including Shell, have set internal targets to reduce the expenditure by about 30%. And the 30% cost saving can primarily be achieved by thinking in a different way. So what I will show you is a couple of the big examples of decommissioning globally, and then zoom in into how decommissioning cost can actually be reduced, and how we need the input from the supply chain and our service partners into that thinking. So the next slide is the latest world record in decommissioning. So you can see here a vessel called the Pioneering Spirit, which was a purpose-built vessel for decommissioning activities, although it can also do pipe lay and actually installation. But what this actually does, it can actually come along and completely remove in one go an integrated topside. So the topside that you see in the picture is one of the Brent platforms. This topside was built in the 80s, and it was built in a modular form. So there was a deck built offshore, and the various modules were lifted one by one. So this platform was not designed to be installed or to be removed in one single lift. However, with this innovation from the firm Allseas, getting this Pioneering Spirit, they built this twin hull massive. It's the biggest vessel in the world, where these arms go underneath the platform and actually manage to lift the whole topside off in one go. Now, if you're thinking about that 30% cost reduction, what it actually does is actually taking the hours that you need to decommission away from offshore and bring them onshore, which means logistics and labor cost and availability of vendors will become a lot cheaper. So this is an excellent example of how innovation and new technology can aid the decommissioning industry. I've lost my slide. I now see myself. Can we get the slide back on? Thank you. Oh. That is not my slide.
Put Rob's slide.
Mr. Gautam Singh, can you please stop sharing the screen?
Mr. Padam Singh, please. Prasanjit, put it back.
Yeah, thank you. So what then happens is that this catamaran lift actually puts the topside down on the bars that you see on the right, and then the topside is skidded ashore. Now, again, this is a new technology, because what you see here, the quayside that this topside is being offloaded on, is one of the strongest quaysides in the world. It will require a significant pressure per square meter to actually be able to lift this topside onto the shore. Once it's actually on this landing pad, then the topside will be torn apart using hydraulic shears. If we can go to the next. Previously in the Gulf of Mexico, they also thought about how they could reduce the cost, and they came up with this concept of the claw, which is effectively also a twin hull thing that can lift complete topsides. This contraption was also designed to actually deal with damage after hurricanes, where rigs would actually topple over and fall into the sea, and this thing can lift them out and bring them to shore in one go. So that is, again, a piece of innovation that reduces offshore exposure, reduces cost, and moves it to an environment where it can be more controlled. If you go back one slide ahead again, thank you. Sorry, one slide forward I mentioned, apologies, confusion. That one, yes. This is one of the very early topside lift. This is the Le Mans platform that was done about 8 or 9 years ago. And you can see, again, this was an integrated lift. But the difference is that this platform was actually intended to be installed in one move, and it therefore can also be removed in one go. And therefore, this type of lift is far more common for the more modern or platforms that were installed at a later date, that were installed as an integrated lift. If I can ask you to move one slide forward again, thank you. So what is different between construction and decommissioning and dismantling? As I mentioned, I believe that the construction of the platforms is a very mature industry. Yeah, it is exciting, it's got a continuous improvement mindset, and both the service companies and the operators want to have a very high level of control over the installation. We want to have a platform that meets high quality standards so that we can have a high uptime and basically get a smooth running platform out of it. Contractors are very experienced, and most importantly, the projects are always schedule driven. The moment the platform is installed, your revenue stream starts, and therefore schedule is a major part in the value of your project. If you compare that to decommissioning, it is a relatively new and emerging territory. It's whilst in, say, for example, in the North Sea, about 8% of the stock has been decommissioned so far. You can see that the forecast is significantly accelerating, and therefore there are significant opportunities there. It requires a completely different mindset. The level of quality control is significantly different. You don't need to torque your bolts open again. You don't need to have very specific requirements in margins. You just need a blowtorch and a big hydraulic cutter and let things drop to the ground to actually get it into small pieces. It also means that we get a new set of contractors in the business. Contractors that are more in that demolition mindset and that actually also have the tools and the technology to do that, but that are not necessarily used to working with the oil and gas industry, and therefore also not necessarily used to the risks that the oil and gas industry brings to the demolition industry. Most importantly, it has that wide execution window, and the Topti team use that to their advantage to basically say there is no revenue stream after the decommissioning effort. You need to work with the contractor, and you need to listen to the contractor how they want to decommission a project and when they want to do it. By maximizing the use of the assets of the contractor, you can actually come to a significant win-win that leads to an improved outcome for both parties. It does mean that we need to let go of the control. We need to be far more hands-off. We need to trust the contractor that they know their business. Shell is not a decommissioning company. Shell does not aspire to be a decommissioning company, but we have a significant decommissioning scope. What Shell wants to do is listen to the market and work with the market to understand how we can both do this together, how you would do this and what you need from us in order to do a successful decommissioning project. One of the very best things in decommissioning, it is a mandatory process. We don't have the options. So how can we get to success? You need to be safe, you need to be responsible, and you need to be cost effective. Those are the only three things that count in decommissioning. Schedule is not in there, and that is a major differentiator from other oil and gas projects. It needs a mindset change. Yeah? You need to have that demolition mindset. You need to be able to learn from other countries because decommissioning is shifting over the world. And you should also learn from the supply chain and the novel supply chain in there. You need to understand your requirements, who your stakeholders are and what your stakeholders want out of your decommissioning. Most importantly, and I think also an opportunity for the India and the Southeast environment, is how you can work together. How can you bundle scope between operators such that you can actually get to a more efficient campaign? Yeah, topsides is far better served with.
Rob, you have 2 minutes. Rob, please come.
Yes, thank you. This is indeed also my last slide. So I want to get to the TOPT project. The TOPT project is actually is in an advanced stage of decommissioning. It is a field with a number of, it's got a central processing facility, and it's got a number of normally unmanned wellhead platforms. They did tender the whole thing. They gave the tenderer the free hand to decide the execution methodology. They focused on negotiating how the risk was going to get managed. And out of that, the cost will follow. And in the end, with that strategy, we actually were able to select both bid in there. So the last slide, please. So here you can see where we currently are. We have the contract signed. The bridge between STP and TPP has been removed. The subsea diving campaign is removed. The lifting lugs have been installed, and it's now waiting for the next season for Boskalis to come along and lift the platforms ashore. They will be brought ashore in India. With that, I would like to complete this presentation. If there's any other questions, please use the chat box or come back to me. Thank you.
Thank you, Rob, for a wonderful talk on decommissioning. The special mention was the catamaran lift, which is being deployed to decom at a faster rate. The differences that you brought about regarding construction versus dismantling were at least educative for our audience. A significant thing that you mentioned was leaving out strict timelines and schedules while doing the decom and looking for safe, responsible, and cost-effective decommissioning. That was a, I think, learning that Shell had. And you need to collaboratively work with a decom contractor, because not every company is a decom company. So thanks, Rob, for bringing in that perspective on decommissioning. Now we move on to our last speaker, who was not the last, but due to technical glitches, Mr. Padam Singh, Vice President ENP Sun Petro. He would be talking about innovative solutions in small fields. Mr. Padam Singh, please.
You're not audible, sir.
So,
yes, we can hear you now. Yeah.
So, would you please show the presentation, because I am not able to share from my system. Is it possible to open, sir? Okay.
You can also shift to low LD.
Okay. Yeah. Thank you very much to all the DGS team who provided the opportunity to us to present our effective, cost-effective innovation carried out by our company for all our field. These innovative solutions are being implemented in all the fields, depending upon the usability. So our company have done as on date more than 20 innovation, done more than 20 innovations, which are very, very useful to us and very, very cost effective for our operations. Here I will go one by one. First is sun hydrocyclone. This is the substitute of produced water conditioner. So in place of produced water conditioner, we will be installing hydrocyclone, which is designed by our team, and it is working on the principle of that we are entering the fluid in the tangential direction, and the cyclonic the centrifugal force is working to separate the emulsion or oily water and the pure water. Here the inlet will be the produced water, and top one, if you see, it will be the pure it will be the oily water, and bottom one will be the pure water. The pure water which is going out from the hydrocyclone we designed, it will be having oil content up to 10 ppm. So this is very, very compatible for disposal, further disposal, and we have a plan to dispose this water into the nearby well. So this is very, very cost effective. It cost to us about 5 lakh rupees, whereas the conventional system we provide, it may cost about 1 crore rupees. Next, please. Here, yes, please.
I think you have 20 odd slides, so I think आपको 10 सेकंड में एक slide बताना.
Okay, I will go. This is the use seal we provided. This is also an innovative method to put a restriction in the flare line, and you can divert the flare gas to the recovery system. Next, please. This is cyclone inside the separators. We designed the cyclones in which we have put in the inlet of the separators, which is increasing the efficiency of the separation. Next, please. Pigable Y. Actually, we laid the collector line from north to south, and in the between this line is getting connected to our CPF. So we need to provide a Y, which was very, very important for us to put the pig from both sides. So this is a unique system designed by our team, and it is being installed. Next. Yeah, actually, we temporarily start the pump, respiratory pump, which was to be used finally for our disposal, for our produced water disposing into the well. So this pump we managed to operate smoothly, having the NPSS control in the suction. So we design in-house, and it is working very well. Next. Ejector. Actually, as I told many times also in DGS, that we will not be flaring any gas. All the gas which is liberated in the separator will be put for use and to the local consumers. We have two stage separation, first, second, and third stage also we have a stabilizer column. Even the stabilizer column, which is liberating gas about 500 to 1000 cubic meter per day, will also be sucked by the ejector. It is our own design, and it is already tested, and it is under fabrication. Further improvement. Next. Yeah, actually, you know that in the collector line, the oil and gas will be coming in surges, and these surges damage the separator. So before the first separator, we installed this surge control system. It is our own design, and we can share many things with DGS and other team also if they want. Okay, next. Flare tip also, it is our own design, and it is being installed now. This flare tip will not be distinguished in case of windy air or something. It is best, and it is also sucking air, and will be always working very efficiently. Next. Dry seal. Actually, dry seal, we have, actually, you know that there are so many NRV like thing we have to put, but NRV never work properly. So we design our own dry seals, which are being installed in between the line, and before that we are diverting the gas for ejector. Yeah, seal port. Yeah, in the test separator, mobile test separator, we are making unique mobile test separator, and this mobile separator will be moving to all the well locations for testing the well, and this facility will be having a unique facility in the country. It will be measuring all the phases, water, oil, and gas, and will be putting the fluid back to the flow line. So there will not be any wastage of any fluid. Next is gravel pack. Actually, in Modera field, we were having loose sand reservoir. So we design our own sand, this gravel pack, which is working very efficiently, and we are not getting any problem of sand. This field could not be produced by the earlier operator because of the sand problem. Next. Actually, in Modera field, there are two reservoirs. One is Kalol and another is Cambesale. Cambesale is below and Kalol is above. And Cambesale is having gas as well as condensate, and above Kalol is having very heavy oil. So we designed the ejector in such a way so that the bottom one, which is at high pressure gas, it is creating vacuum near the upper zone, and we are sucking and providing the better drawdown for the upper zone. So this is most effective and very good for operating in the field, for getting the better fluid from upper zone also. In our Bawala field, this is the unique way we are producing oil and gas, because it is a very difficult field. So we are maintaining, we are running the PCP pump, as well as we are operating. We are following the annulus. Annulus is following oil and gas, but tubing, we install PCP, it is pumping only water. So we are managing the RPM water and also the flow of annulus in such a way so that oil comes through the annulus and water come through the tubing. If we change the RPM, RPM is very important of the PCP. So we are maintaining RPM and the beam in the annulus in such a way so that we are producing oil efficiently. Next. Actually, this is a very simple system we provided. Actually, in fact, our crude oil in Bawala is very viscous, and it is also the thermal conductivity of this oil is very poor. Heat transfer is not taking place. So we designed the heating system in such a way so that we increase the surface area of heating. Next. Yeah, this is also one of the simple way we created. We are putting this unit on each well head, and using the same energy of the well. We are not putting any pump. It is a gravity injection. It can inject the chemical at any pressure of the well, or even at the bottom of the bottom hole. We can inject the chemical also through this unit. So this unit is very effective, and we are installing at all the wells and also in our CPF. This is one unique system we developed and fabricated. It will not be having any control valve, anything. It is controlled. The flow is controlled by the gas head as well as the liquid head. The difference density of the gas as well as the oil is working here, and it is efficiently being operated. Next. Yes. Yeah, actually, we wanted to know how much gas is coming from our Bawala and Modera field wells. So we have a very simple system to measure the gas. We installed a orifice at the tank at the top of the tank, and from delta P is the pressure which is measured in the U-tube of water. That is the delta P across this orifice, and we are measuring the gas very accurately. So we have very simple, and our operators are recording the gas, how much we are producing from the well. Next. Reservoir MPCT we already applied in Modera and Bawala field, and we have a tie-up with the Ukrainian company. This is the best way of producing heavy oil. It is some sort of a exothermic reaction it provides in the reservoir, and it heats the reservoir up to 270 degrees centigrade. And also it percolates near the Wellbore about 1 kilometer radius. So this technology we are going to apply for the other field also. I feel that this may be very effective for our Hazira, even Bhaskar also, to produce better. Next. Plasma, we are working in association with the BRC Ahmedabad and also IIT Chennai. for this technology. Plasma technology we are taking from this ERC, and that is permeate technology for EUR we are taking from Chennai. So our team is working in association with them, and we are developing it jointly. So due to COVID, it delayed by 1 year. Now it will be starting again, and it is very good technology which will be substituting the hydrofracking of the reservoir. It will be costing say $5,000, but hydrofrac, if you provide it, maybe about $0.2 million. So this will be a big saving, as well as this technology, if comes, then other operators can also use it. Next. Yeah, actually in Hazira we understood that in offshore, in some of the well, there is a upper zone which is not even exploited. So this time we are putting a rigless job here, and we are using our crane. If we take the rig, it's very expensive, and for this field we cannot put any expenditure. This is because productivity is very less. So the rigless job is being planned now in this month, and we will be exploiting the upper zone also. We is not kept. Next. The costing, if you see, I think skip it. Okay, next. Actually, I think this is the best way we have awarded the job to the contractors, having CPWD rates, and we taken the best discount on this, and we can execute any type of work. So we not to prepare the tender for small things, and we can deploy the contractor at many locations. We have shortlisted 3 contractors for this job. Next. This is the unique way of doing the job, civil jobs. Warehouse, and we are developing world-class warehouse, and I request DGS team to visit our plant within next month, and find a very good best field being developed here. It is world-class facility we are providing, and I would say here that these innovation way have resulted the cost saving to our company by about 50%. This is a very good thing which I would like to share with DGS when we are presenting to DGS. Next. Even we have not left in civil job. You know we designed the RCC slab in such a way so that it is 4 meter by 8 meter dimensions, and we can create the drilling site within 15 days. Whereas the conventional way, it takes around more than a month. So these slabs we are using at the drilling site and shifting the same to the another locations. So we are saving a lot here. We are estimating around 15 lakh rupees saving for each well on civil foundation. Next. Actually, during this COVID, when we started work at CPF, we found that the RCC work cannot be done. Our original foundation was RCC, and the persons who are working RCC job have already left from the site. They were belonging from Bihar. So we found an innovative way to design the foundation of the tank, because our tank are very large. It is 3,000 cubic meter capacity each, and there are 6 number. So we developed a very good system there, and unique type of foundation. So it is saving very big amount for our company, and also it saved a time. Next. Yeah, it is actually the direction where to have both the simple. I think everybody implementing it, but we are implementing in a very different way, because we are putting all facilities, testing facility, everything facility, and it is really cutting down the cost. Next. I think this is also very common way. So we are saving around 40% on this. Okay, next. This is the last. And there are some more actually, which I will like to give a presentation to DGF one by one, because this virtual presentation, I am not really very comfortable to give virtual presentation. So my team will give a presentation to DGS. I have already sent a request to DGS to arrange one presentation for us, where we will discuss for all the field and also our plan. And I should say here that we are getting wonderful support from DGS and everybody. And with the support of DGS, we could produce yesterday more than 2,000 barrel. And also, I appreciate the support of ONGC. If ONGC allow for more pumping, our capacity, present capacity is around 3,000 barrel per day.
Thank you, Gautam. Thank you for that.
Thank you very much. Thank you for the opportunity.
I believe that the entire audience would have seen that Sun Petrochemicals has almost created a service industry, and I hope it has not sent shivers down Baker Hughes, Schlumberger, and Halliburton. They are producing Sun brand of equipment which can be used and which has been field proven. So this was one thing we thought would add value to this new technology section of Upstream ahead. So thanks so much, Mr. Padam Singh. And now I look forward to Dr. Anand Gupta, the session chair. If he's not in the secretary meeting, he could join with us. Dr. Gupta, are you there? I think Dr. Gupta is still busy in the meeting. Maybe he can come back and join us. So there are a few questions. I hope all the panelists are there. And on behalf of the audience, I would like to put across those questions. One was to Mr. Shobhit Tiwari. In this era of low price regime and the subsequent constraints, what could be done to optimize the stages of fracturing?
So it seems Mr. Tiwari has logged out. He's not here.
Okay, so no issues. We can take that question offline on this. We would go to Baker Hughes and Schlumberger. Absorption of technology in this regime, as was being discussed, how does it really help the industry take it forward in the low price regime, in the constrained environment, in where the industries are not really willing to put in big money. So I believe it would be a long term cycle, but either Mr. Reddy or Mr. Javier could explain.
Oh, sure. Javier here, and so the one of the initiative on the transformation, and as my colleague in Schlumberger would also talk about, the remote operation actually reduce the footprints of our personnel by mobilizing less equipment and less personnel. That reduce the mobilization costs, and ultimate the digitalization and standardization also bring additional cost reduction on the implementation of technology. By today's in drilling assemblies and completion assemblies, now is a big effort of standardizing the modulus. So in that way, the overall cost of manufacturing and the overall cost of implementation reduces. So that's one of the and also the artificial intelligence is one of the key areas where it's being used for not only automation in the drilling, but also in the production management. That area is also bringing tremendous cost reduction on the production management of fields.
Thank you. And what I think the audience is understanding, and I am understanding, is that technology adoption or induction into petroleum operations in the long run will provide you significant gains, though initially you might have had the notion that it is costly at that point in time. So thanks so much, and we would now like to conclude. Dr. Gupta is, I think, Dr. Gupta is there, so I welcome Dr. Gupta. For his benefit, I will give a small brief of what has been talked in this session, and then we will have the conclusion. From Baker Hughes, he talked about the advanced drilling techniques, Mr. Xavier, and about the new wellbore completions. Some of it are proprietary technologies developed by Baker Hughes, and which are quite innovative and also helpful in drilling and completing challenging areas. Then coming to Mr. Shobhit Tiwari, he talked about the multi-stage fracturing that Kane Vedanta has done in RDG gas field, where the volcanic and clastic formations were laminated, and they could do that fracture modeling, and actual results were quite good. So that was put before the audience. Then we had Mr. Gautam Reddy talk about Schlumberger, and he was quite inspired by Dr. Gupta's mention of how these top line technologies can be adopted by all the E&P companies operating in India, some of which get challenged by their tender conditions. Mr. Reddy, apart from talking about cloud-based operations, digital operations, bypassed oil, he talked about the contracting strategy, where also he had an out-of-box idea that DGH could contract the technology and provide it to all the operators who are operating here. So there will be availability on demand, and as the operators want it, though it is very highly unlikely, but that was one suggestion which had come from Mr. Reddy of Schlumberger. Then we had Mr. Rob Jansen of Shell, who brought in the perspective of construction versus dismantling. Construction contractors have a different mindset, and a dismantling contractor has a different mindset. So the E&P companies should, in fact, adopt a win-win collaboration with the dismantling contractors, because we are not going to be the dismantling or the decom contractors. So it is better that we work alongside with them, and so that we have the best of decommissioning at the least possible cost. That was, and in the end, Mr. Padam Singh, President Sun Petro, has put forth the Sun brand of equipment that is being developed alongside the petroleum operations. So he has a spin-off industry, and that has sent quite minds thinking, because we had service providers here, and they might be a worried lot that Sun Petro is giving them stiff competition. So he had over 20 equipments displayed, which during the course of petroleum operations are either fabricated, bought, or installed from different service providers. And Sun Petro has developed the Sun brand of equipment, putting some of which we have already seen, and some of which was innovative. So this is a summary, Dr. Gupta, for you. And now I would request you to kindly close this session by giving your final thoughts. So we are already 10 minutes beyond schedule. So request for 2 minutes of your thoughts, sir.
To me?
Yes, sir. Yes, sir.
Yeah, because sound was broken little. So I think thank you very much, Sudhir, for conducting the session, and thanks to all the speakers. You have already nicely summed up on the issues, and as I mentioned in the beginning, the implementation issues of the technologies are also to be taken forward. And one of the good things in this Upstream ahead has been that a working group has also been constituted, which will be monitoring the takeaways from here. So what I suggest that one of the takeaway can be that how these technologies can be implemented. A small working group under the overall bigger umbrella can be constituted, and try to discuss and try to take forward on some of these issues. As I mentioned, some of the innovative ways, the way Sun Petro has brought, those also can be considered in addition to all the technologies, whatever is being brought out over there. And it has been very good actually that the operators presenting the technologies and its benefits, because our industry generally has been that service providers drive the technologies, but here a benefit from the operators what they have gained and then bringing it out has been a good novel concept over here for the discussion. So again, for that, I congratulate the organizers and the information what has been provided over here. I feel that the information and the presentations, whatever has been made today, will lead to a new beginning and bring a new era in terms of technology implementation. I think 1 or 2 days back there was a discussion with one of the NOC, and they are also bringing some new concepts of implementing the technologies if they can, avoid the route of a typical kind of, tendering. So that also a good thing which is being considered if the technology is adding value and it can be clearly demonstrated, then I think it can be pushed forward. So in the times to come when we are having challenging oil, all that whatever is being discussed moving towards 2050, there will be further support required and technology will definitely play a big role. Mr. Shobhit Kumari's presentation on multi-stage fracturing and the experience of Vedanta has been immense. That I think can be immediately leveraged by some of the companies, including the NOCs, who are considering implementation of these technologies. So thank you, Mr. Tiwari, and thank you, Mr. Xavier. Thank you, Mr. Rob. Thank you, Padan Singh, and thank you, Mr. Reddy, to everybody. And I think it has been a useful interaction. We look forward for further move. Thank you very much.
Thanks, everybody. The session on new technologies in the E&P sector closes here, and we revert back to the organizers for the next session, which is coming up, Atmanirbhar Bharat. So please do join us.